Okay guys, today we're going to do a lesson with the unit circle. I'm going to show you how to fill one out and how to remember where everything is, and I'm going to show you how to use those values to solve trig problems the way that we need to. So the first thing I'm going to do before we fill one out is we're going to go to a website where I can show you can find your own so that you can use it in your own time. I like embeddedmath.com. If I scoot this up, maybe you can see embeddedmath.com. If you go to that page, this free math worksheets tab, you can get yourself graph paper, dot paper, more complicated graph paper, polar graph paper. We'll be using that later in the semester. Special right triangles, trig graph paper, and the last one is the unit circle, and there's a download here. And you'll notice you have two options when that comes up. You have the unit circle, which is completely filled out, and a blank unit circle, which is one that you can practice with to see if you know it. I'm going to show you this one that's already filled out. They have everything nice and neat, and it's really good to study by or check your answers with. I tried to write on the blank one, but it wouldn't let me. So we're going to go back where I can write. It's just my circle's not going to be that pretty. So bear with me. And let's get a screen that you can see. And here we go. So obviously it's a circle, and I'm not going to draw a big circle. I am just going to show you how I sketch it when I have to figure out the problems anyway. So I usually start with an x and y axis and draw my perfect diagonals in, and then lines. There's two more lines, one on each side of the diagonal in each quadrant. There's a little bit of a difference there, and sorry about my not straight lines. Alright, best I've got. Okay, so now the first thing that I want to do is talk about the degrees. The degrees are really easy to remember because the first gap, you'll always start, on the positive x-axis. That's considered 0. So 0 degrees here. The first gap is 30 degrees. The little gaps are 15 degrees. So each quadrant is going to be 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30. So obviously a circle is 360. By the end you should be at 360 degrees. So starting here we have 0. The next line would be 30. And then 15 from that's 45. 15 from that is 60. 30 is a big gap, so I have 90. Then another gap of 30, so 120. Then a gap of 15, 135. Another gap of 15, 150. And then a gap of 30, so you're at 180, and that makes sense. Half of a circle, 180 degrees. Then 30 more, you get to 210. 15, you get 225. 15, you get 240. And then a gap of 30, you get 270. Then we have another gap of 30, so we get to 300. A gap of 15, so 315. A gap of 15, so 330. And then a gap of 30, so all the way around is also 360 degrees. Okay, so next we're going to talk about the radians. Okay, so for the radians, I've got us some cleaner lines, but the first thing that I want you to do is highlight with one color your x and y axis and the perfect diagonals. all of these are going to be multiples of pi over 4 in radians. Again, you start on the positive x-axis, so that is 0 radians. And since those are multiples of pi over 4, you're going to add pi over 4 each time. And it's in radians, so there's a pi on top for this. And so I like to just sometimes kind of cheat it and say 1/4, 2/4, and so on. And then you'll reduce if you can. So we're going to the first one, which is pi over 4. And okay, so we have pi over 4, then we move to the next one because we go around the circle counterclockwise. The next line we have 2 pi over 4, which is going to reduce to pi over 2. So 1 pi over 4, 2 pi over 4. The next one will be 3 pi over 4. The next one will be 4 pi over 4, but we don't generally say 4 over 4. We say 1 pi. So 1/4, 2/4, 3/4, 4/4. The next one is 5/4, 5 pi over 4. 6/4, which is going to reduce to 3 pi over 2. 7/4, so 7 pi over 4. And then 8/4, and again 8/4 is going to reduce to 2 pi. So again, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. That's one whole time around the circle. And you reduce where you can. Okay. Now for the lines that we didn't get. Again, even though you've already done the x and y axis in yellow or whatever your highlighting color, I want you to do the x and y axis again. And then get the other lines that we didn't get before. Now these are going to be multiples of pi over 6, and again we are going to reduce whenever we can. So as I go around, again, each blue line is a difference of pi over 6, and reduce. So start again 0. The first one would be pi over 6, 1/6. The next one's 2/6, 2 pi over 6. That reduces, 2 over 6 reduces to 1/3, so pi over 3. The next blue line is 3/6, and then you'll notice that reduces to 1/2, or pi over 2, we've already got that. So 1/6, 2/6, 3/6. The next one is 4/6. Well, 4/6 reduces to 2/3, so 2 pi over 3. Then 5/6, and then the next blue line is your axis again, 6/6, and 6 over 6 is 1. We already have that. So 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. The next one is 7/6. Then 8/6 reduces to 4/3. 9/6 reduces to 3/2, and we already have it. 10/6 is going to reduce to 5/3. 11/6, and then 12/6 is 2 pi, and we already have that down. So this is the radian part. Okay, now I'm going to talk about the points. We're going to put the points in. And again, you want to remember this is on an x and y axis. A unit circle means it's a circle with a radius of 1. So our center here is technically at 0, 0, or the origin. And if you go 1 unit to the right, which is where we are here, then that is the point 1, 0. If you go 1 unit to the left, that would be the point -1, 0. 1 unit up would be 0, 1, and 1 unit down would be 0, -1. So those 4 points are really easy to come up with. And from there, I start with the first quadrant, the 3 points in the first quadrant. Because if you memorize those, then you can get all of the other quadrants. They're just translations of those points. Because in the first quadrant, you go right and up, which means your x and y are both positive. In the second quadrant, you go left and up, which means your x is negative, but your y is positive. In the third quadrant, you go left and down, so you have a negative x and a negative y. And in the fourth quadrant, you go right and down, so you have a positive x and a negative y. They're all these same points, just flipped into those different quadrants, so they have different positive and negative signs. These numbers are going to come from your special right triangles, and I can show you how to do those in a different video, but I'm just going to go ahead and give them to you right now. The first one, I remember this point here, this pi over 3 point, because on that nice printed unit circle, it looks like it's about halfway between the 0 and the 1, 0. And so if you go halfway to the right, that's 1/2 is your x value. So this x value is 1/2. And it's the same thing for the pi over 6 if you're going up. Between the 0 and the 1, about halfway up, you'll see that this y value is going to be 1/2. And so 1 is the x value, 1 is the y value. The other part of that point is the square root of 3 over 2. It's the y value for pi over 3, it's the x value for pi over 6. The pi over 4 point, again, this comes from your special right triangles. It comes from actually a 45, 45, 90. The other two came from a 30, 60, 90 relationship. The values for this are square root 2 over 2 and square root 2 over 2. So they're the same. It's nice and easy to remember. Okay, so this is the first quadrant, and again, our x's and y's are both positive. In the second quadrant, I said the x's are negative. So if you look at the mirror image, the pi over 3 mirror images to the 2 pi over 3. So it's the same point, 1/2 square root 3 over 2, except you went left. So you have a negative x. Same thing with pi over 4. It mirrors to 3 pi over 4. So it should be negative square root 2 over 2, square root 2 over 2. And the pi over 6 mirrors to the 5 pi over 6. So negative square root 3 over 2, 1/2. And you have the unit circle almost filled in at that point. Okay, when we move into the third quadrant, you go left and down, so your x's and y's are both negative. And if you look at the mirror images here, your 5 pi over 6 looks like 7 pi over 6 in the third quadrant. So both should be negative. Negative square root 3 over 2, negative 1/2. And then your 5 pi over 4 is a flip of the 3 pi over 4. So negative square root 2 over 2, negative square root 2 over 2. And then the 4 pi over 3 will match the 2 pi over 3. So negative 1/2 and negative square root 3 over 2. Okay, and then your fourth quadrant, you should be going right and down, so positive x's and negative y's. And so filling this in, the 11 pi over 6 is going to flip from the pi over 6 with a positive x and a negative y. The 7 pi over 4 should match the pi over 4, positive x value, and negative y value. And then 5 pi over 3 flips from pi over 3. Positive 1/2 is your x value, a negative square root 3 over 2 is your y value. Take some time and make sure you have all of this down on your nice copy of the unit circle. Make sure you have it correct. Make sure you have signs correct. If you are in pre-calculus, we're going to need you to know both the degrees and the radians. And once you move to calculus, we pretty much deal with radians only. So that's the part you really need to study for calculus. Now I'm going to show you how to use those. Okay, the first thing that you have to know is that the points on the unit circle are the cosine and the sine of the angle where they're located. So, for example, pi over 6 has the x value square root 3 over 2 and the y value 1/2. So the cosine of pi over 6 is square root 3 over 2, and the sine of pi over 6 is 1/2. Okay, the thing is, they don't always ask for just cosine or sine. Sometimes they ask for your other trig functions, tangent, cotangent, cosecant, and secant. And that's where you have to remember these reciprocal identities. One that you have to know is the tangent is the same thing as the sine of the angle over the cosine of the angle. The cotangent is the flip of that. It is cosine over sine. The cosecant is 1 over the sine, and the secant is 1 over the cosine. So all the other trig functions that are not part of the original point can be written using the original point values. Now you might have to do some work with that, some rationalizing, some flipping and multiplying, but everything can be turned into forms of sine and cosine and used. You do need to memorize these, so if you need to, write them down and memorize those. Okay, also, before I go into exact examples of that, I do want to remind you about fractions and zeros. If you have 0 in a fraction, it throws people off. So this is how I remember. If 0 is on top, that means it's okay. 0 on top is 0. That's your answer. If 0 is on the bottom of the fraction in the denominator, that is no way. 0 on the bottom means that that is an undefined answer. And so you have those come up sometimes when you're using the 0 and 1 points from your unit circle. So let's move to some examples. Okay, here's our first two examples, and so I'm starting out with cosecant and tangent. And I'm starting with cosecant of 4 pi over 3. So the first thing that you do is locate 4 pi over 3 on your unit circle. So hope you have that out. Find the 4 pi over 3 and the point that goes with that. Then you have to remember that cosecant is 1 over the sine. So what is your sine value? That's right, negative square root 3 over 2. Well, this is not a pretty fraction, and we have to work on it a little bit. So the first thing is, when you're dividing by a number or a fraction by another fraction, you want to flip and multiply. So I have 1 times 2 over the square root of 3, and it's a negative. And obviously anything times 1 is itself. So I get 2 over the square root of 3, and it's negative. But I can't have the square root of 3 on the bottom of a fraction, so I have to rationalize. And to do that, you want to multiply by the square root of 3 over the square root of 3 to get rid of that. So if I go straight across, negative 2 times the square root of 3, and then the square root of 3 times the square root of 3 is 3. So my answer ends up to be negative 2 square roots of 3 over 3. Okay, let's move on to tangent pi over 2. So again, the first thing that you want to do is locate pi over 2 on your unit circle. Find the point associated with it, and it's the one at the top, so it's 0, 1. And tangent is sine over cosine, so there'll be your y value over your x value. So you get 1 over 0. And as I reminded you a second ago, 0 on the bottom means undefined. Okay, we're going to do just a couple more examples. So, secant of pi over 3. Look up your point at pi over 3, and you notice that it is 1/2 and square root 3 over 2. Then you have to remember how to get secant. That is 1 over your cosine, so in this case 1 over your x value, 1 over 1/2. And so, doesn't want to stay. When you're dividing by a fraction, you want to flip and multiply. So flip the bottom, multiply by 2 over 1, and get 2. Okay, and for our next example, cotangent of 3 pi over 4. Again, you want to look for 3 pi over 4 on your unit circle and find the point. In this case, it's a negative square root 2 over 2, positive square root 2 over 2. Okay, then you just have to remember that cotangent is cosine over sine, and so from your point, that would be the x value over the y value. And so that would be a negative square root 2 over 2 over a positive square root 2 over 2. Now some people get so caught up in flipping and multiplying, like we did in number 3, that they flip and multiply here and do a lot more work than they need to. Look at what you have. You have the square root 2 over the square root 2 over 2. Those are the same thing. It's just like having 4 over 4. 4 over 4 is 1. In this case, it's also 1. It's just a little bit uglier to look at. You do have to remember the negative though. So this actually ends up to be a negative 1. Okay, so for these examples, I wanted to throw in some more basic stuff, sine and cosine, where you don't have to do a whole lot but other than look at the point and know what to look for. And to show you that it can be done with degrees as well. And again, for my pre-calc folks, that you have to know how to do both of them. So sine of 270, if you look up 270, it's the same place as 3 pi over 2, and the sine is just the y value of the point. So I'm looking for the y value, and if you have found it, it's a -1. For 330, same place as 11 pi over 6, you're looking for the cosine. Cosine is the x value of the point, and that would be square root 3 over 2. So they're not always complicated like the original first 4. Sometimes they are more basic, and they can use degrees or radians. Throw in 7 in here to talk about negatives. Negatives are when you go around the unit circle clockwise instead of counterclockwise. So 270, if you went around counterclockwise, you would end up going like this. But with negative 270, that means I start here and I go backwards and end up here. Going 270 degrees, still the same amount except I go backwards. And so that puts me ending at the same place as 90 degrees or pi over 2. And so that point is 0, 1. If I'm doing the tangent, tangent is sine over cosine, so y over x. And this time the 0 is on the bottom, and that is undefined. If you need more help with that, just ask.